Hello, my name is Peter Brummel, and today I'm going to be talking about chemical reactions. We'll look at some various reactions and we'll begin to classify them into some main types of reactions. So let's begin. There's three main types of reactions. One is called a decomposition reaction. It basically decomposes things and makes them simpler. There's another called a combustion reaction, which is when things burn, and a formation reaction, when things are formed. So let's look in more detail at what each of these reactions does. A decomposition reaction is a reaction that breaks complex chemicals into their simple components. In example, you can see we have a water molecule right here, and in this reaction it is broken down into its constituents, hydrogen and oxygen. This is a decomposition reaction because the product is simpler chemicals than the reactant was. But what does this look like in real life? Well, here we can see on this left side we have the reactant, and these are two water molecules. On the right side we have some hydrogen molecules and an oxygen molecule. As you can see, the molecules on the right are smaller and less complex than the molecules on the left. That is what makes it a decomposition reaction. Another type of reaction is called the combustion reaction. It's basically when things are burning. For example, as you can see here, we have CH2O, and this O2 is the oxygen that is providing fuel for the fire, which will change it into carbon dioxide and water. And there's two types of combustion reactions. There's one type called complete combustion, and there's another type, incomplete combustion. Basically, complete combustion is when the reactants have carbon and hydrogen in them. So you can see in this example, it is a complete combustion because there's carbon and hydrogen, and also in the product there's CO2 and water. So this example right here is an example of complete combustion. Incomplete combustion is when there is no carbon or hydrogen that react, and when none of the products include carbon dioxide or water. So this is not an example of incomplete combustion. Let's see another example of complete combustion. So here's another definition of it, saying once again that it must have O2 here, and it must have carbon and hydrogen, and must produce carbon dioxide and water. But what does that really look like in real life? Well, you can see here are some of the molecules built out, and we can see here that on this left side we have this large molecule, CH2O, and the small O2 molecule, and that turns into carbon dioxide and water. And so that's what that molecule would look like on the molecular scale. That is complete combustion. Also, there's incomplete combustion, when the reactants don't include carbon and hydrogen, and the products don't include CO2 and H2O. And this is an example of a metal burning, magnesium. When magnesium burns, it does not include carbon and hydrogen, and so the products will not either, and they don't include carbon dioxide or water. And so when magnesium burns, it simply reacts with the air and forms magnesium oxide. Once again, this is what it looks like in real life. You can see that these atoms are joining together to form this oxide. Another type of reaction is called a formation reaction. Formation reactions are reactions in which two or more elements form a compound. You could kind of tell that out of the name. You can see here is the opposite of the decomposition reaction. Here we have the hydrogen and the oxygen making the water molecule instead of taking it apart. So an example of this is we have these smaller, less complex chemicals making up a larger chemical. So that would be a formation reaction. So we've seen there's three main types of reactions: decomposition, when things are made simpler, combustion, when things are burned, and formation, when new and larger chemicals are formed. So here's a practice problem for you to do. Here we have CH4 plus 2O2 changes into carbon dioxide and water. So is this a combustion reaction, a formation reaction, or a decomposition reaction? Well, let's note some things about the chemicals. First of all, we have carbon and hydrogen on the reactant side. We also have O2, which is necessary for combustion, and we have CO2 and H2O in the end. So this reaction is a combustion reaction because it contains all these components that are necessary for a combustion reaction to be classified as one. So in conclusion, we've seen these three types of reactions, and we've learned about what makes each reaction different. So I hope you've enjoyed this video, and make sure to subscribe to this channel. Thank you.